This is the Mr. Forth Programming Conversations podcast. It is provided to all for free. Please consider supporting the podcast and other Mr. Forth projects by going to mrforth.com/membership. Thank you. In this episode, I'm having a conversation with Abner Coimbre. We get to talk about his project Terminal.Click here, which is a terminal emulator paradigm shifting type of project. It's about changing what we mean by the terminal, changing how it relates to other parts of the computing system and environment that it's a part of, and innovating on the interfaces that are possible for controlling processes through a terminal-like interface. Now, I don't believe that Terminal.Click will be out even in a sort of demo form for this podcast, but there is a link that is in the description and that I will read now. This link has a lot of sort of demo GIFs and explanations of Terminal.Click features. The URL to check out is Terminal.Click/podcast. In this episode, we talk about Abner's personal interest in the topic of terminals, how terminals were a part of his original inspiration to get into computing the way he has. We talk a little bit about the architecture of the shell and the terminal, and explore the reasons why Abner has decided to cut with the tradition where a terminal emulator is talking to a shell over a pipe, and instead build a new terminal type interface that does not interact with a shell at all. We talk about some of the downsides that come with cutting the shell, who's impacted and whose workflows won't still work in the new Terminal.Click model. And we also talk about Abner's reasoning for why cutting the shell is worth it and how it opens up possibilities to new kinds of terminal-like interfaces. We talk about some of the features that are already in Terminal.Click, and we also talk about some features that are under development or projected for future hopes and dreams of the Terminal.Click project. And then we get to talk about the general questions of running a personal project, questions about when is it appropriate to ship, when is it appropriate to spend more time, how do you make sure that you're producing something that is quality to give to people, but also not holding on to it forever and being too precious. And that's an interesting topic on its own. So I hope you enjoy this conversation. I think it's got a lot of interesting stuff. So without further ado, here it is. All right, welcome, Abner. Welcome back to the podcast.
This is so exciting. This time as a programmer proper, I suppose.
Yeah. Last time we were talking about your conferences, and that's still what you do mostly to make a living, but you do program as well. And so this time we get to talk about something you've been programming on for quite a while, this project Terminal.Click. And Terminal.Click, for anyone who's just stumbling into this for the first time, is, you might say it's a terminal emulator, but I think that we're going to find out that that's not quite the right thing to say about what it is, but it's something along those lines. It's like a terminal emulator somehow. But I'm really fascinated about this topic because, I'm working on a series of podcasts these days about the idea of sort of non-textual programming, where the thought is we have this interface for constructing software that is made up of text languages and text editors, and it is sort of kind of becoming a dinosaur to me. It feels like an old paradigm, and I'm curious about new paradigms. Now, you're working on a terminal emulator, which is not an interface for constructing software, but it is an interface for manipulating and running software and systems, and it's also text-based. It also has its roots in a legacy dinosaur past that is not very user-friendly. It is also an interface in need of the same kind of revitalization. So it feels to me like there's probably some synergies going on between the stuff you're thinking about and what should happen in Terminal.Click and the stuff I'm looking for and what should happen in non-textual programming someday. So it's going to be really interesting to get into some of those ideas. But before we look into like the big far out ideas of Terminal.Click, I'd like to start with the more grounding thing of sort of why did you start working on a terminal emulator? Why is that important to you?
Absolutely. Thank you for having me again at the podcast. I'm pretty excited. And if your listeners kind of want to check out the terminal right away, because it hasn't shipped exactly yet, at the time of the recording at least, they can visit this website that I hope to keep long-term, Terminal.Click/podcast. And hopefully people can check it out if they want to. So sorry, your question was about the kind of like the history, what led me to it, things like that.
Yeah.
And it's interesting. So, as you said, what I do these days is run tech conferences, mostly for a living, but I haven't stopped programming. And part of that has to do is I grew up in love with, obsessed with computers very much. And my first interaction with computers had to do with hacker movies. And we're talking cool hackers, where it wasn't, when you use a Windows machine, what you had was command.exe, which is like a very boring kind of like interface. But if you watched the movies, you had, pinching, zooming, interacting like 3D holograms. And it wasn't just like a little black box. And I was like, wow, this is cool. Is there anything like this that is cool for us, for my family computer? And there was really nothing because it was just Windows. But thanks to those hacker movies, I remember using not Google, but like Yahoo or Ask Jeeves or whatever it was back then. Like, hey, I want to find out about cooler terminals. And that led me to Linux. And I learned how to partition the family computer to use Linux in order to use a more interesting terminal. And then I just grew up learning programming in C, actually, that way. It was for writing terminal-oriented programs. So like, how can I make like a little visual, not visual, but like, how can I create like a little MP3 player on one of these terminal tabs and navigate directory? All of that stuff is how I learned programming. So I just became in love with the idea of making terminals better, even at that young of an age. Then I got very lucky with an internship at NASA. So that's when I left my home in Puerto Rico. I went to Kennedy Space Center. And lo and behold, the work done at Kennedy Space Center is in like these old school launch control computers. And launch control computers very much use VGA consoles, right? And the work that you do is also very much on a terminal. So much of my work at Kennedy was not using graphical user interfaces and things like that. And then I jumped to the video game industry. I think I talked about it in the last podcast. Like I ended up working for Jonathan Blow and then the creators of the Myst game. So that was game development, but I was very much there as like a tool person, low-level person, still using terminals a lot. And obviously, spending so much time with that tool for so long opens up kind of curiosity of like why we are stuck the way we are, right? It felt like, okay, there's a lot of power actually locked away in this dead text interface. Like if the listeners go to the terminal website, I'm saying I'm trying to bring dead text to life. Because it's kind of shocking that for so many decades, since the 70s, we are still using terminals in this way. And today, even with like modern operating systems, modern computers, we are still using terminals in this old school way where it's just you type in some text, you get back some text, and that's it. It's really weird. Why haven't we innovated in that space? I'm really confused. So I went into a rabbit hole basically a few years ago, I want to say, maybe 3 years ago at this point, like a serious rabbit hole, right? Like let me actually understand how terminals are constructed, like, and what makes it difficult to innovate there. And I think I answered some of those questions. It was pretty grueling. And it's like, oh, okay, it's pretty tough. I can see why it's hard to innovate there, but it's not impossible. Like it's not impossible. There might be some sacrifices that we have to make. Maybe we can talk about those sacrifices that we have to make. But if you think those sacrifices are worth making, then yeah, you can definitely evolve and level up the terminal emulators that we use today. And that's what I'm trying to do with my project. It's like trying to level up the experience, level up the workflow. And yes, it ties in with your idea of like visual or non-textual programming in some degree. So I'm excited.
Awesome. So you said something about roughly 3 years ago, somewhere in there, you did a deep dive to figure out more details about what's really going on with how terminals work. Is that how long you've been working on a terminal emulator tool, or is the project, is that a piece of the project? How long is this project, or like the terminal itself been something you've been curious about working on?
It's pretty close. I would give it an extra year to say basically when COVID started, where I started to prototype. Like, again, in a very serious way, prototype, experiment, play with things. But then to really go into the literature of Linux kernels and like, why is Windows so alien to build terminals for compared to Linux or Mac OS, and like all of that serious like literature deep dives was about 3 years ago. I want to say 4 years ago when COVID started is when I really, I guess, had the time as well because lockdown, right? to just play with all of this. Yeah.
Gotcha. So I guess I'm curious about wherever this started for you. It sounds like there was a lot of terminal usage throughout your career, and even before your career, there was some elements of the terminal that inspired your interest in computers. So it sounds like something you've probably in the background been thinking about. But since the project has started, how has your ideas and vision of what you want to be doing with your project sort of evolved? Did it always look like what you're shooting for now, or were there some light bulb moments where you thought this is really what is going to make Terminal.Click special?
Yes, it has evolved and changed a little bit over time, but the idea has always been, can we make this more interactive in a graphical sense? And that means being able to click on it, if you think of the mouse, of being able to have UI elements, GUI elements, kind of like being a part of the terminal experience. And if you remember, I don't know, Alan, if you've ever heard of Temple OS, but yes. So Temple OS is a famous or infamous project that did innovate in some respects. And like there was even a tech journalist who actually decided to look into it and wrote an article about Temple OS, like what are the good parts about Temple OS that this tech journalist thought was good. And it included the terminal. And I saw that the way Temple OS was using terminals involved a lot of like, let's build in a file explorer in here that's clickable, that's like navigable and all of that. And I was like, whoa, okay. That's interesting to me. So but I guess what I'm trying to say is that even though what features I'm shooting for has changed, what kind of features I want to ship maybe has changed or keeps changing, the core idea is let's blur the boundaries between text and graphical interactions, very often involving the mouse. It's not that you can't use the keyboard or hotkeys to activate certain elements in the UI or anything like that, but it's always been about let's blur the boundaries between text and like more visual richness to it, right?
That makes sense. So there's a talk you gave, I think maybe a little around a year ago at the Software You Can Love conference, where you really went into detail about the relationship of the terminal and the shell. And I was wondering if you could review a little bit of that topic for us now, because I'd like to ask some questions about the special things that Terminal.Click has decided to do with relationship to the shell. But, I'm conscious of the fact we probably have listeners who have the same surface level understanding of the terminal that I did until I heard that talk, which is that the terminal takes in inputs and sends out outputs from other programs that it runs. And there's something called a shell that's something about scripting and environment variables. But I didn't know things like that there's a process separation barrier and that basically all of the work is happening on one side of the barrier and not the other. And so if you could review that topic for us, that'd be nice.
The first thing is I think we should dispense with the word terminal entirely. I'm going to give you a snapshot of how this works real quick. It's almost like, how do you explain somebody the Mona Lisa? Well, you can watch the Mona Lisa yourself in person, or I can show you a picture that I took of the Mona Lisa where I was there, kind of like blocking the view a little bit, doing a hand wave. So I'm going to give you an explanation that's a little bit lossy, but it's still pretty accurate in its fundamentals. So I will dispense with the word terminal because many people get confused with what we mean by terminal because there's so many interlocking parts, like you said. There's many interlocking parts to make the whole terminal emulator ecosystem work, that when you say terminal, it's almost not that useful. So if I get rid of the word terminal, then what do we have left? First, we have the emulator. And that is what I would imagine your listeners will interact with a lot. That is the actual application that spins up when you press the start button, type in terminal, the application comes up. That application, that graphical representation, that is the emulator. And why is it called an emulator? Well, it's simulating like a dumb device from the 70s and the 80s. Anybody who's a listener who might be on a retiring age, comfortably retired, hopefully, may have experienced this when they worked as a programmer, like in a university faculty or some IT department back then, where all you had was a dumb device. It's just like this screen and this keyboard. There's not really a CPU in there. It's not really a computer. It may look like a computer, but it's not. It's just this dumb device. And it's connected through like a serial cable, literally, right? A serial cable to like a faraway mainframe, like this giant ass server machine. And that's the actual computer. And so you would run programs, and that program on the server, on the mainframe, would send back information to that dumb terminal, to that dumb screen, right? And then you get text rendered with like whatever. And that's all it was back then. And in that era, so many interesting programs were written that we don't want to kind of like give up, right? We're talking a huge number of programs. This is the era of Vim being created and Emacs being created and you name it, right? All of the programs that we use today many of the popular ones were written in the 70s and the 80s. So we're like, okay, but now we don't program this way anymore. And so decades go by, we have our own personal desktop computers, we have our own personal laptops. So technically speaking, we could dispense and just get rid of this old architecture of things, of like terminal, dumb screen, cable, none of that. But that would require porting literally thousands of legacy programs that assumed this old architecture, right? This old setup of things. So let's actually simulate and emulate the whole thing using software. A software emulation of like the old architecture. So that's basically what's going on. When you fire up your emulator on your modern Windows or Linux or whatever, that's the emulator, that's the dumb device, right? And when you type in a program, again, Vim or a compiler, Make, you name it, what's actually happening is there's some Linux pipe, for example, that's being created between that emulator, between that graphical application, and the program and the process for Vim format. And now they're communicating only through text. And that text gets displayed on the screen. Now you might ask, wait, hold on, because emulators can like react with like colors, and the cursor can move around, and it can like ring a little bell, right? So like, what's going on? It's like, well, if all we can do to control an emulator is through a text stream, that's all we have, then I think we need to embed certain sequences of bytes, and mostly starting with an ASCII escape character and a bracket for some reason. So you have some ASCII escape character in a bracket. That's a magical sequence to say, okay, anything that I'm going to read from now on, if I'm an emulator, I'm going to interpret as a series of commands rather than text to display verbatim, right? And that's how you control cursor location, color, font styling, triggering. All of that is all happening just through a single text stream. The text stream is the only way you can communicate how to control the behavior of an emulator, right? And so we have not dispensed with that. I would imagine, Alan, that maybe you have called on some of your programs printf, and in printf you use some little magical codes to like change the color to green on your emulator or to red. Like,
yep.
All programs these days that run on a terminal are printfing, basically. They're calling printf, just passing in a text stream with a series of escape characters of like magical sequences, certain sequences, to control the environment, the actual emulator. And that hasn't changed at all. Now, one more thing is the introduction of the shell, which I guess we're now getting closer to what Terminal.Click is trying to innovate on. We also have a shell, and that means, when maybe you want to run a program, but it's going to take a long time to run, maybe you want to hide it in the background when you're in your emulator so you can run other programs and things like that. Well, that doesn't happen automatically. You need some kind of manager, I call it, right? Like this manager behind the scenes that is like taking that Linux pipe, right? And saying, okay, this pipe was going through for Vim, but the users just asked for Vim to hide in the background because now he wants to run a server. Okay, so the shell kind of like, takes that pipe away from Vim and connects it to a server or connects it to a different program, right? Like that's all being controlled by this idea of a shell, right? But all throughout this process, you can tell that the emulator, all it's doing is parsing like a state machine just the sequence of bytes, that's text stream, and reacting to it byte by byte. And it has no understanding of what's going on at all. It is only on the other side of the barrier that this shell actually knows what programs are being run, what things are being managed, what the user's intent is. That is the shell. But if you think about it, the shell is also connected at the other end of this pipe, which means it is a text-only program. It is, Bash, for example, is the most famous shell, but there's also Z shell and all these things. These are programs written in C, right, or C++ or whatever, and like they just connect it to a pipe and like tell the emulator to do things. But that's that. The emulator has no knowledge of what's going on. And I guess to finish the innovative comment here, what I've done with Terminal.Click is say, you know what? What if there's no shell? What if there's no manager? And what if we let the emulator, again, the graphical application, actually buffer up an understanding of user input? So in other words, instead of letting a user type in Vim, any typical terminal right now, any typical emulator will take Vim, the letters VIM, and pass them along one by one down the pipe, only for the shell to understand on the other side of the barrier, right? It has no idea that you're trying to run Vim. It has no idea that you're trying to run Clang or GCC. But now, because I killed the shell, my emulator now needs to basically adopt the responsibilities of the shell and know that you are typing Clang, that you are typing GCC, and the emulator needs to know that that's what you're doing, so it can find the binary, right? So it can create the pipe and connect the binary to the pipe and let the text stream flow happen. But now with just that little change, now all of a sudden, this emulator understands user input. It knows that you're trying to run Clang. It knows that you're trying to run Vim. So why not also create some internal data structures to be like store metadata about that command? Like, hey, okay, so Clang was run. The emulator knows this. So, okay, let's create a little metadata here about like how long it took to run and whether it succeeded or not and like what the output was. And let's show that in a visual way, in a graphical way. Let me show you that history. Let me show you what's going on, because now I've moved away I've shifted, I guess. So the responsibility of understanding user input has left the shell. It has now come to the emulator on the graphical side. And I can marry the power of like understanding of text input with the graphics API, I suppose, right? And now visual things can happen beyond just text. And I hope that was a good summary of where the Terminal.Click is coming from.
Yeah, I think that that makes sense. I'm going to summarize it and then maybe dig in just a little bit on certain features, because I know that it's a topic, again, like I said, that you kind of can take for granted when you learn how to use the terminal or the command line, if you want to give it like a more neutral name maybe. When you learn how to use a command line interface, you kind of just take for granted that it works. And the fact that there's this architecture of sort of division of labor and pipes in between these pieces is a little surprising. It's not the way you would imagine building it if you had to build it from scratch, at least in my experience. Like learning about it, it felt that way at first. Like it feels kind of funky. So to summarize, your Terminal.Click is you would call it a terminal emulator, it sounds like, because it does do things like color codes at least. So it does some of the things a terminal emulator would do, but it's not, if I'm understanding you correctly, it's not set up to talk to a shell. It's not set up to have a shell that manages everything. It's going to take over the responsibility of sort of doing that process management. And so it no longer plays the game of pretending that it's a dumb keyboard and a dumb screen that doesn't know what the letters mean when you type. It knows what the letters mean when you type. It knows what processes are going on and what the thing that's displaying the interface and the thing that's doing all the management are now one combined problem space, essentially, in Terminal.Click.
Correct. Well said.
Okay. So to dig in just a little bit, because I think, I know that there has been some folks who have heard the killing the shell talk who are concerned about different things that'll go. And honestly, there's some of these I'm not even sure myself that I know quite where the lines are. So I've got kind of a bullet point list of features that are important on a command line. And I'm curious if you can just answer, like, does this go when we kill the shell? Is there a way to recover it? Or no, this is actually fine. We can still do that just day one without the shell.
Mm-hmm.
So if you want to elaborate, you can elaborate. If you want to give a quick answer, you can do that. But I got a few of these here. So let's see. What about what if I want to write scripts, like my bash scripts? Are those out the door now, or does running a bash script work in Terminal.Click?
They are out the door. Fundamentally, when you fire up any typical emulator, any typical command line, what's going to happen is that emulator immediately creates a pipe, so to speak, and fires up the shell, fires up bash, fires up Z shell, whatever the user configured. And now it's waiting on user input, and then whatever you type on the keyboard will be sent along for the shell to process, right? So that's gone. That is gone. And it is bash. It is the shell program that can execute at runtime scripts, bash scripts, and things of that nature. That is their job over there. That is the shell's job over there. And now that's gone. And there is a way to do like a one-off bash invocation. So you can invoke bash if you really need to. So, and I'm not even sure whether it's something that should encourage, allow, or even just like, even just say like, yeah, we're not gonna have any shell whatsoever. Like, I actually don't even know yet. At the time of this recording, I haven't shipped this terminal to the audience. I'm not sure where to go there. But my answer is yes, it is gone. And then the question becomes, okay, well, if Terminal.Click has no shell and it's not connecting to any shell, and theoretically, I guess you could connect it, but you're not really going there, then shouldn't it be the Terminal.Click's job to find a suitable replacement for bash scripts, and then what's that going to look like, et cetera, et cetera. So it is a huge point of contention. I have had a lot of users who have grown up with shells in IT work, sysadmin work, saying that it is a non-starter to lose bash scripts and to lose that shell environment, because so much of their workflow is tied to that. Like they fire up a shell, like they source .profiles, or like they set up a whole environment variable list all through this bash script, and like now that's gone, right? Yeah, it's a huge, I guess, to say, yeah, it's gone. And my job as the creator of this terminal is to say, we can build better replacements that don't need this like text kind of scripting, right? Like we can do better than that. We can go beyond the dead text. But I will admit that, well, maybe there's a feature I want to talk to you about later in this podcast that maybe hint at that direction. But so to speak, right now, yeah, it's gone.
Okay. Yeah, that's a tough pill to swallow. But if a dinosaur text file system is out the door and it makes room for a new scripting system, I'm obviously all on board for that. But it is always hard to lose all of the created like software that people are relying on in the meantime. So you mentioned in there another one that I've got on my list, which is environment variables. Aren't environment variables managed by the shell? Is it impossible to set an environment variable or manipulate them without a shell?
To my understanding, the shell does a lot with environment variables, but that doesn't mean that they can't exist. So even without it, so for example, when you run a program on Linux, at least, the runtime image of the binary, I suppose, like when at runtime you take that the kernel, the operating system takes that binary and does a bit of hot patching with global offset tables and like dynamic loaders, whatever, right? There's also a part where it says, okay, here's a list of environment variables actually, and when you call something like get_env, which is a very classic Unix API function, to get that list, that's just pointing to a place in the runtime binary image, and there's your environment variables. In other words, yes, you can play nicely with environment variables. You can still have them exist without the shell.
Okay, cool. Now I know the pipes are a part of the architecture between the terminal emulator and the shell and the programs that the shell is managing. But ignoring those pipes, there's also the idea of pipes as in like when you write down a command, especially on Linux. I actually don't think Windows has an equivalent, but on Linux you can run one command and have its output pipe into another command. So a pipe in that sense, is that something the shell needs to be there to have, or is that something we can recover?
We can recover that.
Okay. What about file I/O? Like, same idea, but instead of between processes, reading off a disk or to make an input stream or writing to the disk to create an output stream.
We can recover that. There's no need for a shell.
Okay. And last one, what about like remote sessions, talking to my server through my interface instead of talking to the local computer through my interface?
That one's harder. That's a more interesting topic, because when you don't have a shell, or not even the shell, just like breaking down the traditional architecture of things, right? When you do that, then a lot of assumptions about networking with a terminal, SSH, and all of these things, like that becomes difficult, but not intractable. I guess it's something that I haven't tackled yet, but you can definitely have these visual workflows, this Terminal.Click way of doing things without the old school way of doing things that could work over a network. Like that, there's nothing preventing us from making these things work over a network. It's just making sure I do the right kind of like architecturing on the code base, and maybe making a more specific protocol, I suppose, right? Or even taking the traditional protocol that we have right now. So as I was talking about the text stream, right? And that's how we communicate with the emulator. It's just a text stream. And because that's all we have, that means we have to embed these magical sequences, right? To specify behavior. Like that is a protocol. It's been classified by the ISO ANSI standard. Like it's well known. Like there's no reason we can't take that, embrace it, extend it, and make it work with our new system. Now, for me, all of the features that your listeners might be checking out on the website, all of those features are local to the machine, at least for this first iteration, for this first version that I want to ship. So that's another tough pill to swallow, at least when we first ship. When we first ship, it's like, oh, I lost my bash scripts. That's one. So, oh, I can't use these awesome visual features over the network. That's also another tough pill to swallow. But it doesn't mean we can't make it happen. It's just, if I want to ship this terminal ideally this year, I cannot touch those topics because it is quite the complex rabbit hole, right?
Gotcha. Okay. Sounds like, as you summarize, scripts and the remote command execution are the two things that are more deeply tied up in the shell emulation system that needs more work to unravel.
So the two biggest losses, yeah.
Yeah, so this might be a strange question because I know we've kind of covered possibly two answers to this already, but in your opinion, because we're still on this topic of the cutting the shell and the fact that there are folks who are not fully on board with that, what, in your opinion, are the best reasons people have for being concerned or not wanting you to cut the shell?
Yes. That's an interesting question. You're almost having me play devil's advocate here. I love that. Okay. So definitely it is the destruction of so many workflows, right? Like there's such an ecosystem built over the decades of, hey, I know that if I SSH into this remote machine, there's a lot of affordances and conveniences that I get by just running this one bash script, or by, I don't know if you've heard of the term sourcing, but it's a command called source. If you call source and then you pass in what's called a .profile file, that's just listing all the right environment variable aliases for your commands, like shorthand, conveniences, everything. Like it's almost like a historically encoded workflow for like a job if you're being onboarded for a new job. That all lives in this ecosystem of the shell and the script and the environment variables and like networking through SSH. And again, so much of the web development world hinges on being able to SSH and have all of these shell affordances that are text only, but they're powerful, even if it's text-only interface, that they're powerful, you're losing that. You're losing that. And I understand that fear, right? Especially since I'm not, at least for this first version of my terminal, I'm not providing like a nice transition for it, right? Like there's no way to transition off of that into my new system. So the way I would look at this is even maybe try to say this might be for a different target audience. Or even maybe if you're working in IT or in sysadmin right now, you cannot switch to Terminal.Click perhaps because of these big losses. But if you're using it for anything else, like you might be unlocking a lot of power. So if you're using it just, I am a developer that I'm always on an IDE, right? I'm on Visual Studio Code, or I'm using a debugger and I'm compiling. And every once in a while, like the network goes down and I need to fire up a terminal to like invoke LSPCI or like do a little bit of like debugging or troubleshooting, all of that. And it's all local, right? Like, Alan, even you do this, like, because you have developed a lot of desktop software. Every once in a while, when you're creating desktop software, you need to fire up a terminal. And it is there. It is in that moment where Terminal.Click can really shine in productivity. So I guess one way I could say this is I agree that the loss of networking conveniences, the loss of bash scripting conveniences is probably terrible when it comes to a typical IT job, because I don't provide a transition path for it. But if you are using the Terminal.Click for local work, you're just on your machine, you're creating desktop software, or you just need to debug something locally, I think that's where it's going to shine. And I bet you there's so many people listening to this podcast right now who just use their terminal every once in a while when they have to, when they're on their machine locally. That is when Terminal.Click can really make a difference.
Yeah, thanks for that. I did want to have you play devil's advocate. So now the flip side is, since you did that, you're clearly thinking about where Terminal.Click is going to be strong and weak on its first iteration, and you've made the call to cut the shell, just knowing fully well that a big portion of the industry that relies on the terminal is cut out by that. So the flip side is, what are you getting? Like what are some of the good things that you're unlocking that you were kind of alluding to them, but I wonder if you could tell us a little bit more about why is it worth it to you, more specifically.
Let's talk about one feature in particular. And this is the one that I am revealing for the first time in this podcast. So I'm excited. And I don't even have a name for it. It's going to be very interesting to talk about it with you, because I've never verbalized it either. But this is a visual feature that I feel that in the old school way of using the shell, like this would have never come up. So the idea is, imagine you are trying to run the compiler or trying to run make. You're trying to compile your project. So that's one command. That's one action. Let's also imagine that as maybe you're making a video game, or you're making something that involves assets and things like that. I mean, I've gone through this. Like I said, I've worked in the video game industry where I have to run an asset packer. Basically, you might have a bunch of individual sprites, individual images, that then when you run your asset packer program, maybe you pass it in. Maybe your artist has created a bunch of Photoshop files, right? And you want to turn those Photoshop files, all of them, into a single sprite sheet, tightly packed, optimized for your target CPU. It could be a Nintendo Switch or Xbox. It doesn't matter, right? So that's another command. That's another behavior that many people run on the command line, by the way. They run their asset packer on the command line, and as arguments, they feed it a bunch of Photoshop files or something like that. So it's another kind of behavior. And maybe you even have another program that really all it's doing is have like a little backend server going on with like logs being spit out, for example, because I don't know, the game you're making has a little bit of like a networking component to it, and there's some logs being spit out on a server, and your server's on localhost, so it's all good, it's all local, no problem. And we can go on, right? Maybe another program is just like searching for keywords when the log gives you a keyword that's an error. It's like, oh, I want to flag that. So you have a separate program kind of like grepping continuously for that server output. So I've given you a number of behaviors that you would run on the command line. And so the feature that I have is, okay, let's run the first one to compile. So make or GCC, passing the arguments, all good. and you press a hotkey, and in the hotkey you enter into this new mode where when you're ready to run the compiler, all the text is going to transform into like this little terminal machine, this little dumb screen, like old school, like an old school little sprite of like a machine, and that little machine icon or like sprite represents the command that you're about to run. Right, and like it just highlights, like it turns on, the screen goes, I'm not even sure how to explain it, but basically it's basically your command turns into an animated sprite. Okay, it doesn't even matter that right now the animated sprite is like a little computer, old school computer. It can be anything. It can be any sprite. It's a visual affordance. Okay, and now that little machine is like whirling and like shaking a little bit. Just to tell you, yeah, I'm running the compilation. Like, that's all good. And then you can type in your next command, which could be like let's run the asset packer. And as you're constructing the asset packer, you can highlight, okay, these arguments that I'm passing are just like the Photoshop files. And now Terminal.Click is aware that these are the files being passed to your asset packer, and it's going to keep track of them. That's actually going to be important. But anyway, so now this next machine, you press enter, right? This next machine comes to life and it's now whirling and asset packing your thing, right? Now, let's remember here, nothing's changing in terms of like the command line programs themselves. The command line programs themselves are like any other command line program from any other terminal. What's happening is that you've entered into this interesting mode on the emulator, on Terminal.Click, and you're telling it, okay, run these programs kind of like behind this little sprite image, right? It's just tucked away in there, it's just hidden. And then you run your server, another little machine comes, and now you can see basically there's these little machines showing up visually on your terminal surface, and they're just whirling about and running and like all of those things, right? And like when they stop running, you can click on it if you wanted to, and like it opens up the screen of the computer machine in a much bigger way, and it's showing you, here's the output. Here's the environment variables at the time. Here's how long it took to run. Here's the success rate. Right? And then you can maybe make the machine smaller once again and like shake it, click on it, literally with your mouse, click on it, shake it, and it runs once again. So it's almost, so in a way, if you want to like, you're making changes on your code base on the editor or something like that, and you're ready to recompile again, just go to that one machine from earlier, give it a shake. And then now whirls up again, and that's running. So for one thing, that's also a nice way to save time. It's just like, boom, right, to the thing. Now, because my Terminal.Click has a built-in file explorer, again, if your listeners have been looking at the website, Terminal.Click, it has a built-in file explorer. If you're starting to like open up little sprites or like, because again, you have this asset packer, right? You're just opening up the Photoshop file, so you're opening up the images and like you're editing them on Photoshop itself or like Paint or whatever, and you save it. And then you're like, oh, you know what? I'm going to make a new folder. I want these sprites to live in a new folder. And then you're just doing all of these movements around it, right? Not a problem. You can just shake that machine that is representing the asset packer command. You can shake it, and it'll just run the asset packer, no problem. Because even if you moved around the files, when you pass in those original arguments to the asset packer, it doesn't matter that you move them around to different folders, that you move things around, because we're keeping track of that. So you can just run the little machine again, and like the asset packer will work no problem because it kept track of all the files that you moved around that were arguments for that asset packer, right? And then finally, if you have this is like the nodes and wire idea. I'm not sure if I'm going to keep it or not. I'm just experimenting. This is all an experiment. If you have like a really long-running server program that is represented by this machine sprite, click on that, and now a little cable comes out, and you hook that cable into another into another little machine, right? And you can even construct this machine without associating it with an old command line program. You can construct it to say, I'm constructing this machine, and whatever cable goes into this machine, listening for the text stream, and any occurrence of this keyword or any occurrence of like this pattern, notify me. Like maybe have the machine bounce around and things like that. Or in my case, in this current implementation, it just makes a noise, or it does like a little bubble on top of like the machine that says, okay, I found an occurrence of this keyword, like error or warning. and all of that stuff. So now these machines can interconnect with like these little wires that I'm dragging in and around. So that's the feature. It's an interesting way to, it's really anything beyond what you would expect from your typical experience with the terminal. It's really way out there, right? But it works because the Terminal.Click application understands user input, and now I'm using the full power of the graphics API to marry that with like user intent and like play around with it a little bit. And I can't imagine making this work in a trivial sense with a shell. I just don't see that. I don't know if you do.
Yeah. Well, I don't know enough about the architecture of the shell, but I could imagine it would be quite difficult if, like, again, I don't know how much shells have, and there's this protocol part that's really the sticking point. Like, you could write a shell to do all the things you're talking about, except that it has to communicate things like, oh, this program is running, oh, and at the same time this program just finished, and oh, at the same time this program just sent an alert to the thing here. So like it has to in parallel use the protocol for all these things all the time, and that's possible in theory, but at some point it starts to feel like the feature you just pitched feels to me like it starts to strain the degree to which it's reasonable to shove everything through a protocol, which is usually the way you would think about like trying to get the shell to communicate more of its state so that the graphical side can then turn that into an interface. At a certain point, the weight of that, it's sort of like a protocol is like a straw, right? And there's all this information on the shell that has to get shoved through the straw, and out the other end, the terminal has to be able to decode all that information coming through that straw and turn it into an interface. And you're saying, you know what, I don't have a straw, so I can like fire hose information from the running states of my programs into the interface.
And I'll tell you this, I had a conversation with Michio Hashimoto, who it's on the Terminal website, by the way. It was a conversation because he's writing his own terminal emulator. We're good friends. We're like friendly competitors, right? And his terminal Ghost TTY. Ghost TTY, his terminal emulator, works with a shell, no problem. And in our conversation, we basically agreed that I have a lot more freedom to do all these visual experiments, like this feature I just talked about. It's going to be wild when people see it, because you might even think like, this is not useful. Like, why do I want to shake a little game looking sprite to like trigger my compilation again? I don't want to do that. It's like, fine, right? But it's the fact that I even get to do this in the first place, right? With real command line programs now behaving and interacting with like these game-like behaviors. It's amazing to me to experiment, right? Where if this was all, like you said, shoved into a formal spec in a protocol in a straw, like at what point do you think this is a ridiculous waste of time in terms of like friction, in terms of like experimentation, productivity, like all of these things just melt away when I just kill the shell. Now, Michio Hashimoto's point to me, because we talked about this a little bit on the conversation, is like, well, I can still make this happen. He told me like he's basically watching my project pick up all the cool visual features that I am doing at blazing speed, because I have that speed of iteration, experimentation, and he's going to find the best ones and make them work with the shell. Yeah. It's like, well, good. Okay, good for you. Good for you. So but like you said, what's the threshold though? Like, at what point is it a little too ridiculous though?
Yeah. That's a really interesting question. I think that a part of what you were saying, and I started anticipating this because what you're basically describing is the first baby steps of a visual programming language, as far as I can tell. I mean, you've got independent nodes that just represent doing work, which is not usually what a visual programming language is like. But then the model of nodes and wires fits very nicely as a sort of describing the data flow, which sounds like that would be your replacement for the pipe operator on Linux. But if you imagine taking that the next step farther, it's like, well, if it is a visual programming language, then can I save my networks of interconnected programs to a file and load them up again tomorrow? So, it might be tedious the first time I construct it, but how much more tedious is it to maintain and understand a script that's that complicated a year later versus the visual representation of the pipe network or your pipeline or whatever it is, right? I could imagine getting to a point there where any representation with less fidelity than the one you described just isn't as good of a feature, and at the same time, it's almost it feels like you're if that's not impossible to do the way that Ghost TTY would try to do it, it feels like it would run into really serious problems of like, well, what's the performance going to be like when everything gets smushed down into this byte stream and unsmushed later to describe these networks of interacting independent programs that you want to be able to reinstantiate that entire network or portions of it and stuff like that. So
Yeah.
it feels like also the beginning of a solution to your scripting question is what you're talking about.
That's right. And what if these programs, like I just said, I have this one program where it takes in arguments, and these arguments are files, and I can keep track of those files being moved around, by the way, and the program runs just fine. So I would be interested to see that being encoded in some kind of protocol for the shell, because that's pretty wild. And
Right. Yeah.
And I would also add one more point. And again, this is no, like I said, Mitchell and I are friendly competitors, and I wish him well. And who knows who's going to win out? In some ways, I'm not even sure who's going to win out. But I do have more speed, and he acknowledges that I do have more speed of experimentation. So I'm going to take that to the nth degree. Here's another one. And I haven't implemented this, so this is not an actual feature. But I kind of, if you'll allow me, I'm actually going to pick your brain here.
Sure.
This idea of destructive and non-destructive behavior of things. Like, can you imagine, I guess in this visual programming way, in like this series of little machines and wires, and who knows what other visual affordances we can add beyond just machines and wires, by the way, that I haven't thought of. But like, as you're creating like this visual language, like, can't you simulate what might happen as a result? So for example, you know how when people these days, they'll accidentally call RM, this is the remove command, and like force a deletion of a folder that's like, oh, I didn't want to delete that folder actually, right? Or like they accidentally changed the number of environment variable values and they forgot what the previous ones were because there's no history for them. And all that stuff, like this is all destructive behavior that you're doing. So much of the raw commands you run on the command line are so destructive to the file system, to the environment variables, to status codes, like the history is gone, all of that stuff. Why can't we have non-destructive ways of playing out what these series of commands are going to do before you actually do them? And I can't even begin to imagine how to implement this in a more generic way that works for any number of command line programs or something like that. It sounds out there. Like I'm not even sure where I could begin there. But like, you can also even think about basically constructing an undo tree.
Yeah.
So maybe it is destructive, but you have an undo tree, so maybe things get buffered up in a way that lets you rewind. And how far, which things can you, I guess it could be an exercise of like classifying which operations on the terminal space are destructive no matter what, but which things can be simulated in a message. Like there's a categorization problem here as well. So anyway, sorry.
That's a really, really interesting question, and I'll give you a couple of thoughts on it. I think the first thing that pops in my head is that you're going to bump into a very similar problem to what I bump into when thinking about visual programming languages, which is that like visual programming languages for software construction rather than for system manipulation. But those problems that I run into tend to that are similar to what you're talking about are this like bumping up against the fact that it's all being iterated on and experimented on top of an operating system that is also a dead text operating system, essentially, right? So what is a file path? It's a dead text method of talking about what a file is. You are manually tracking when a file moves within your interface, I assume, right? It's not a matter of...
That's right.
It's not a matter of if I went to the external operating system explorer and moved the file around that you would magically figure out that the file disappeared from here and popped over there. It's because it's through your interface. And I think that's a point you made, or a point I didn't make that I am realizing now as I'm talking about it, is that's something that I don't see how you would ever recreate that without going through a visual interface that is more powerful. Like the visual interface is now allowing you to capture information that you could not capture on the shell side. The shell is now the one that's too dumb. It's because we set up a dichotomy of the shell is smart and the terminal is dumb. But there is, once you have a visual a file browser, a thing where even if you did add a shell back in, now the shell would be too dumb because it wouldn't know things like files moving around is happening, which is interesting on its own. But you are still in an operating system that has made a bunch of decisions that are coherent with a dead text terminal and a dead text programming language environment. So you're going to have problems like if I decide to, using the C standard lingo, if I decide to F open and modify a file and then F close that file, what is Terminal.Click going to do about that? Like, how are you going to make an undo of that? You'd have to have captured that. Now, you might say, like, oh, we'll make a Terminal.Click specific CLib for C. But it's like, okay, what if I'm in a different language? What if I use the operating system low-level access to the file system, right? Like, there are so many problems there. It's the kind of thing you might be able to do, but you might have to start redefining how programs relate to each other through redefining how they relate to the operating system to achieve some of what you're talking about. On the other hand, the other thought that pops in my head thinking about that is, and this only gets you so far, because a big part of obviously the reason Terminal.Click is interested in considering whether or not it runs the shell at all is because it's not just a visual system. It is still trying to run commands. It is still trying to run legacy stuff, right? Like one of your demos is you can run the donut, the donut animation program. So you do preserve a lot of the historical programs that we want to be able to run. They can at least run, scripts set aside. Scripts are the big exception.
Alan, I've broken too many hearts. I already broke too many hearts with like no bash scripting and no networking. Do you want me to go further and say we can't?
Right. So because you have that, because that's important, there's nothing we can do about the fact that old legacy programs aren't going to know. But I could imagine if I was a programmer, let's say a game company, right? Because asset packing and compiling my game and all that stuff was a good example. And I get used to Terminal.Click in my workflow. What it pops in my head is once I get used to, say Terminal.Click, we can't do anything about if the program chooses to read and write files on its own. But Terminal.Click has complete visibility into the input and output streams of all the programs that it's interconnecting. And I might suddenly think to myself, hey, you know what? I want to rearrange the style that I use for writing my personal commands so that the way that they're written will talk to Terminal.Click in a richer way. And so then if you have, because, this is a feature that's been in Terminal.Click since as long as I can remember, and I'm sure people who are checking out the website have already seen it, but there's not only is there the visual browser, but you can visually drag and drop files off of commands and onto commands. Like you can get the output of a command and turn it into a file, even if you forgot to do that when you invoked it, which is nice. So a thought that popped in my head listening to you talk about if I have a server running and a wire to another machine that's going to do, maybe it's another program, maybe it's just a Terminal.Click feature node.
Yeah, or it's just sniffing for a keyword or something. Yeah. Mm-hmm.
But again, in Linux land, if I were to do a pipe between two programs, I would again lose that data in the process. That I would not have any way to recover.
That's right.
All the stuff that was sent. But Terminal.Click could just decide, you know what? We'll keep a log of what the streams were like. In addition to sending them between the machines, we'll know what happened on each wire. And then if you want to do the same drag and drop stuff you've always done, that's just now it's tap into this wire and show me what data is flowing through this wire. Show what data did flow through this wire. And the point of all that is to say there is a lot of potential for speculatively doing things without committing to it, right? You could set up, if I wrote my program so that they're all data streams in and out and there's no reading and writing to stuff on the disk, then I could imagine Terminal.Click offering, undo, redo kinds of things through those interfaces at the very least. And then I just have to discipline myself to build my programs in a way that interacts with the part of Terminal.Click that supports that. I don't know if that pitch makes sense, but that's kind of how I pictured it. If you had to undo redo just at the level of your streams, then I could start writing my own programs at the very least to take advantage of that new affordance.
This also makes me think of, I guess, what are the limits of my own creativity as the author? If, as you can see, if I'm stuck in this land of like bots or little machines and wires, and other more creative users are like, wait, we can, your idea of like visually constructing operations is limited. Like I have far more interesting things that I think, like, hey, just like give me internal access to your engine or something. Like I want to be able to like write programs where I can ask Terminal.Click for information about. So let's remember this, because Terminal.Click can store a lot of metadata associated with a command. Like again, you run your compiler. We're storing a lot of metadata there. Here's what the environment variables are at the time. Here's how long it took to run. Here's the success code. Here's what the output was, right? If we did it through like the little bot or machine, whatever, like, oh, here's the pipe that opened up and like it was redirected over here. Like all of that is now something that maybe the user, the creator of programs who wants to take advantage of Terminal.Click knows exists now. So like, let me tap into that, and also give me access to like the surface of the Terminal.Click. Like, in other words, give me access to like the GUI powers. Like, I want to be able to like create sprites, create visual affordances myself, little GUI elements, and all these things. So with those two powers, with the power of I can ask what the command is up to and what the metadata is, and the second power of like, now let me draw interesting things related to that metadata or whatever. Like, it's almost like a plugin system ecosystem, right? Where I can expose a world of plugins for people to do the things that I don't know how to do myself, right? If I'm just shipping Terminal.Click with like a small number of visual features, and you're like, oh my God, like you're really limiting yourself. Like, wouldn't the ultimate expression be that I give the user power to write their own visual plugins? There's no way for like this first iteration, Alan, that I'm going to give that power to people, even though I want to, yeah. Right? It just seems, once again, in the same way that I've killed the shell in the name of productivity and for other reasons, and I've killed networking for now, like it won't work over the network. I'm also killing the ability to write plugins for it, because that's just a level of complexity that I don't know how to take on to ship right away, you know?
Yeah. Well, I'll tell you what I think about that, if you don't mind. One, I think you're right that it's too much complexity. And two, you got to be careful about creating plugin systems. You only really create a good plugin system when you get very clear about what plugins can't do. Just like how an operating system that was built on a dead text ecosystem, like Vision, like the Unix tradition that we inherit in all of our operating systems today, is based on the idea that programs will be like C files. They will be translated into executable data from those C files, and we will interface with the file system and the devices through a textual interface called a command line, and then all this will fit together as one big text-based interface for controlling the software of this computer, right? That is the Unix tradition we have. And that operating system decides what it means for programs to coexist. And so that's where we run into that problem we talked about a minute ago, that you can't undo everything, because it wasn't decided by the operating system that there would be a way to say, for instance, I'm going to launch this program, but only in speculative mode. So make a mark that we would have made a file, but make the file virtual and hand it back to the containing context so that it can be passed along by the containing context in an appropriate way, or whatever you could imagine a kernel that's set up for this kind of sandboxing that is necessary for perfect undo of the file system changes. But you don't have it, so it doesn't matter unless you want to build an operating system. Similarly, you could come up with a plugin system, and if it happens to be crappy, it's the one you'll be stuck with until someone reinvents the wheel on you to fix the crappy plugin system that didn't really decide the good way for plugins to work together. The other thing I would say, though, is in a way you already do have a plugin system, because of the fact that you can run external programs, even though the only affordances I have, like on Terminal.Click, as it exists right now, even if it doesn't have, let's even say it doesn't have machines and wires at all. It's just basically the same thing as a command line, but with better file browsing and some other features like, better management of the files on the command line and stuff like that. Even with just that much, the fact that I can write a program that then gets run by your program, and the inputs that I give to your program integrate with the inputs to my program, and the outputs from my program integrate in a way back to the outputs from your program, means I can make a plugin, right? That's what the command line is it's the ultimate plugin system for a very simple interface. So it's
a good way of looking at it, yeah.
So I don't think you need to think so much about how do I make a plugin system for right now, as much as you need to think about the stuff you are thinking about. Like, how do I make an interface for controlling programs? And if your interface for controlling programs has the right affordances, then I can create programs to take advantage of those.
Absolutely.
That is a plugin, right? That is the more fruitful and interesting direction that you're already exploring, I think. So,
I also wanted to mention, by the way, I agree. I agree with all of that for sure. I wanted to mention as well that I'm glad that this works on Windows too, because for the longest time, terminals and all the cool stuff about them only lived in Unix land. It only lived on Mac OS. It only lived on Linux. And this was because any terminal author that was trying to do something interesting anyway would almost never touch Windows. And it has to do with the fact that because terminals, as you know, they're so tightly coupled to their environment, to what the operating system, what the kernel gives them. Pipes. And I've been calling them pipes. Like, we can actually break this down. It's actually more complicated than pipes. I've just been using pipes with my Mona Lisa example earlier. I'm just giving you like a lossy picture of what's going on, but it's actually far more complicated than pipes. And yeah, you need the kernel to cooperate with you a lot. And it's so tightly coupled to the Unix universe that Windows way over there does nothing like it, at least until recently. Recently, Windows said, you know what? We do want people to write better terminals for our operating system. So they created this architecture called the conpty API, which the summary of the conpty API is essentially, now you can, if you're creating a terminal, now you can use the same kind of language, so to speak, as you're creating terminals, as the same language as Linux, as the same language as Mac OS. And that just means in the past, you couldn't create a pipe to connect the emulator with the program on the other side or with the shell on the other side. These days, now you can create a pipe, so to speak. On Windows, these days, now you can use all of the escape code sequences and like magical byte strings, and all of that stuff now works. Because of that, Terminal.Click actually works on Windows. It works on Mac. It works on Linux. And it's all native, by the way, which is also very exciting. It's not like this React app or this Electron app. Everything we're talking about, even just imagine, I'm trying to think how many terminals out there. It may be rare. I think it's exceedingly rare to find a native terminal emulator that works across all three operating systems with the same number of like keyboard shortcut ergonomics. Like, it's all mapping 1-to-1. Even just that alone is like such a great experience to be able to like fire up the terminal on any OS, any fresh OS, and you get the same shortcuts, you get the same visual interface. It's the same terminal. Like, that's a great experience to have. Just thought I'd put that out there. It's easy to overlook, but I think it's a nice little experience that you can have. You've unlocked the power of good terminals on Windows now, and we have that. So that's nice.
Yeah, that is pretty nice. I feel very similarly. I love it whenever I have a program that works the same across operating systems, and especially when it's also able to run on the native layer, or if it doesn't, at least is still as performant as possible, which you don't usually get off of something like an Electron-based solution to the cross-platform thing. But it sounds like, and correct me if I'm wrong here, but it sounds like even if you were on Electron, you couldn't have gone cross-platform without some better support from the Windows operating system, because Electron isn't going to change the fact that you've got to be able to talk to the kernel and set up the right kind of pipe.
Yep. anytime before 2018, the year 2018, you couldn't write these kinds of terminals on Windows. You could not. You could not. Or not without great performance costs. Right? Because you had to do some weird scraping situations of like text being sent out to some console. It was gross. You couldn't make it happen natively. Now you can. Since starting in 2018 until now you can. So it took you a while, Microsoft, but good job.
Yeah, that's really cool. So I do hope people have checked out the website, because there's a lot of features we didn't talk about today that have been in Terminal.Click for a while that are pretty cool and that I'm excited about. I'm also really excited to see this feature. It might already be out for people to see by the time they're hearing this, but I haven't actually seen what Abner described today about the machines and the wires, but it sounds
Really
really cool.
exciting.
I've been really hoping for something that really busted out of the terminal form factor, and it sounds like that's where you're going, which is exciting. I think as a final big picture question, I wonder if as you reflect on the process of design and steps you've taken in your project and trying to figure out what's a useful way to spend your time to feel good about what you're doing, is there anything you've learned about whether it's terminal stuff or design stuff or just programming stuff or project? What's a lesson that you feel like you are taking away from your time on the project lately?
That I have never shipped anything on my own, and I did not know how much this was going to cost me. In terms of sanity, the years that I think it feels like I said, I've been doing this since COVID started, basically in a serious way, and I didn't realize how long this was going to take. So, which is funny, and I want listeners to understand that again. I always say I worked for NASA, right? I worked for the big guys, Jonathan Blow, and like all these things. Like I have a pretty storied career, I have a pretty good resume, and yet nothing could have prepared me to ship something solo. So many of my projects have been on a team, have been with coworkers, have been with a supervisor, with a boss. All of these things, doing it on my own really opens the horizon for just the kind of grit you need to have all of these years, and the kind of humbleness you need to say, I need to throw this entire part of the code base out the window and start over. Like just very, very difficult decisions that hurt your morale, make you think you're not that good or, or, or that competent. So I went through that multiple times. That's the reason I've taken so long to ship, actually. It's just like, oh, I should not have done this. In fact, I'll give you one quick example, because you know, I've been inspired by your Mr. Forth YouTube videos where you teach people how to create their own platform layer or how to develop a refinement of their memory management strategies. And just thinking about rendering, all of those concepts, like the boundaries of like API, function, parameter design, you know, all of these things that get into interesting philosophical debates. Funny enough, before using those YouTube videos to learn more, I was calling malloc and free everywhere in my code base. My platform layer was not rigorous. It was always leaking, let's say. I would have like conditional compilation happening across different functions when that should have really just been designed away into like proper OS function platform layer kind of thing. Like so many of those things were like scattered across the code base, just like poor memory management and conditional compilation and like things breaking and like macros, too many macros and all of that stuff. When I watched your YouTube videos and I said, you know, I'm probably going to unlock a lot of productivity and a lot of maintenance benefits if I switched over, but it also cost me. I guess my ego was bruised, and so right, I had to go back. Yeah. No wonder I'm suffering so much with like these leaks or these buffer overruns or something. And it's not that arenas. By the way, I'm talking about arenas as like one of the main ways that I use memory management now is using arenas. It's not that it solved all of my memory management problems, but oh boy, has it reduced them like crazy in such a fantastic way that it was worth the ego bruising. It was worth the ego bruising to then like chuck out a lot of the code base and like recreate a new platform layer, adopt yours, all of that stuff. Like that was necessary. And that's the one example I'm giving you, but it's happened in other ways too, right? Where it's like I had to like look at the code base and go like, yep, that's not it, or yep, that's not it, and like try over. And now this year, since I'm hoping to ship this thing this year, ideally ship an alpha, get it on users' hand, on your listeners' hands. I feel like, okay, at some point you do have to ship, right? But it is an interesting question of like, okay, I do have to ship, but I'm glad I did go through this growth, this phase of growth as a programmer before shipping. What's funny is I'm pretty sure, Alan, that even after I ship, a few years later, I might come back to this and say this was not good. Like this was not a good way to structure the code base. This was not a good way to deploy arena strategies, like blah, 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 blah. But at some point, you do have to say stop, right?
Yeah.
You have to stop and you have to ship. So that's an interesting question of like knowing when to stop doing this, reevaluation and reflection over and over. Like I feel like I'm ready. After 4 years, I want to ship, But
yeah. I'm looking forward to you shipping, and I'll tell you this too. You did a good thing. I shipped 4Coder very early on in the process. Like I started putting out builds, and luckily there was a long time before I put anything out that I really locked into. But still, I ended up with like 3 iterations of my project config format that I had to sort of simultaneously maintain the converters that would like preserve your old projects from a year ago, because I realized that like my format was not sophisticated enough to handle really basic stuff that people were actually going to want. I didn't know how to think through features and plan them before I put them in people's hands. I deleted your entire text editor one time.
I remember that.
There were a number of times that I was just like, I'm putting out stuff that is really not ready, or it's not going to last very long before I'm going to have to replace it. And the upside to putting stuff out early is you learn what shipping is like, but the downside is you do have layers of cruft that you just live with forever, because you can't replace everything fast enough. And it sounds like you're already feeling like you're at that spot, like you've replaced some mistakes, you cleaned up from certain things, but you can also just know like, yeah, you put out something that's pretty good. You're always going to be taking that ego bruising, though, of like, it's a couple years down the line, for sure not a single thing that you did was the right thing. But it was the right thing when you shipped. It just stops being the right thing very quickly. That's what I think I learned from the process of shipping.
Would you give any guidance to the to the audience of like when to, because this is a question of like, you shipped 4Coder early, and it was in many ways a success. I don't know if Terminal.Click is going to be a success. I hope so. But I can already say a personal success for sure in terms of growth. But it does suck that this is not on users' hands after 4 years. So what would we recommend, like the typical programmer who's like into the way you build software, who's into the way that I build software, when is the right time for them to ship? Because it sounds like you and I are on opposite ends right now. You shipped early, and I'm shipping pretty late. Yeah. Which one should they pick?
That's a really interesting question. I think that's hard to pick, and it really comes down a lot more to what feels right for you. I think that shipping is a personal decision, especially if you are doing a solo project. If you're running a business and getting things out on time makes or breaks people's jobs, then I think that you ship whatever you've got on a deadline. But I think that when you're doing what I did and what you did, it is a project of passion, which means it kind of has a lot to do with your own personal psychological journey in life. It's not just a piece of code, and it's not just a piece of software. It's also kind of an expression of where you're at and what you're up for. So ship when you're up for dealing with people's feedback, and if that sounds terrifying, then you're not ready. And if you shipped and then you found out you shipped too early and it's humiliating, then you can learn from that too. Like it's a personal thing though. It's really about, I think you have to, for solo projects, I don't think that there is any rule at all. It's too much of a personal journey thing for there to be a good rule when you're doing something, especially like by yourself or completely out of passion.
I love that. So if we have a listener shipping early, or what they think is too early, and somebody else shipping like they feel like it took forever, either of those things can be valid actually. If it's a solo project, a passion project, it's like what their psychology allowed them to to do. And as long as there was growth, I mean, it's going to be growth with shipping too. I can't wait for that kind of growth that I want to have. I can't wait to hear feedback. I mean, I've shipped conferences, so to speak, going back to the beginning, that I run conferences. In many ways, I see that as shipping, right? Shipping a conference is this idea of like, so much of my conferencing software I wrote myself. So technically speaking, it got shipped, but only for one user. It got shipped for me, but it's not the same. It's really not the same as shipping user-facing software. In this case, desktop software. It's going to be completely foreign to anything else I've done. That's a part of my growth that's missing, and I can't wait to do it. And even if it fails, let's assume that your listeners get to try it out, maybe at this point, and it failed. Like, it just wasn't that interesting. I really grew as a programmer, far more than I expected. Even though, like I said, I do have a storied career, but it's not the same as doing it solo. Like, so many muscles as a developer get trained that don't get trained when you're stuck in a team. And it's not bad to be in a team, obviously. Not at all. It's good to collaborate. It's good to be in a team. It's a good idea. But there's something that only happens when you're alone, like certain skill sets, certain mindsets, like certain kind of like refinements that can only happen solo, I think. So, yeah, I can't wait to get the feedback phase of it, though.
Yeah. Well, I'm looking forward to it. I hope everyone listening is looking forward to it. Thanks so much for coming on again, Abner.
Yay! This was so much fun.
Yeah, likewise. I'll hope to have you on again someday. Maybe when you've got a couple years of feedback or something, and you gotta parse
more
it
ego
out.
bruising. Yeah. More humbled. Okay, sounds good. Bruise my ego. Okay.